Alrighty, good morning there, seventh graders. Happy Monday. Today we are going to be continuing our lesson from last week. Last week we had learned all about using addition and subtraction phrases in equations. This week we're going to be following the same thread, but we're going to be covering the remaining two operations. So I need you to make sure that you have a pencil and a piece of paper in front of you. You're going to be taking some notes today. Go through, and this is a really great skill that you are going to need to know for eighth grade and beyond, is taking notes. And that's just listening to the teacher, following along, and writing down anything that you think is important. I'm going to give you a little bit of an idea of what I think you should be writing down throughout this video, but make sure that you have something in front of you to be taking. This, I'm thinking, is going to be a 2-day video. Today, we're going to get to example 1. Tomorrow, we're going to cover from example 1 to 5. And you guys will have a short little assignment that will go along with that. But besides that, I hope you all had a wonderful weekend. Know that you can always contact me during my office hours between 9 and 10:30. I'm always available to give you a hand and to help out a little bit. Otherwise, there's one other thing I wanted to tell you, and that is about the help link. I posted a help link at the bottom of most of our videos that links to a Khan Academy video that will just give you another little dose of help. If you know what, maybe you realize, hey, Mr. Engel, I prefer hearing from the guy from Khan Academy. You can absolutely log in there. Alrighty, but without further ado, we're going to begin here. So CK12, there is a link on Google Classroom. It's multiplication and division phrases as equations. You should open that up and see this cute little bunny right here. So there is a bunny population behind Ishmael's house. Ishmael is helping the local park ranger track the population numbers. At the start of July, there are 127 bunnies. Well, that's a lot of bunnies. 127 females, actually. By the end of the month, Ishmael and the ranger count 415 new bunnies. What is the average number of bunnies that each female had during this time? How can Ishmael write an equation that shows this solution or this situation? Our concept that we're learning about today, and I'm on this row right here. In this concept, you will learn how to write multiplication and division phrases as single variable equations. So we're going to be focusing on multiplication and division. We've done this a lot this year. We have divided and added rational and irrational numbers and integers, and we're just going to keep on rocking and rolling here, my friends. So, writing multiplication and division phrases as equations. Just as you can write addition and subtraction expressions from words and phrases, you can also write multiplication and division expressions. You can use keywords to help you with this. The more familiar you become with the keywords that identify a multiplication and division expression, the better you will become at writing expressions. Here are some phrases that can be translated into multiplication or division expressions. What I want you guys to do right now is I want you to please pause this video. I want you on your notepad to please go through and copy down, make 2 different charts. So make our multiplication phrases and our division phrases. So take a few minutes here, pause the video, and copy down our 2 multiplication phrases and our 2 division phrases. Make sure that you have the examples with them as well, okay? So pause right now. Alrighty. So getting back into it, you should have written down your multiplication and division phrases. If you have not done that, again, pause the video, do that now. Remember that these words are only a helpful guide. You can always think about which operation makes sense for a particular situation. So let's go through here. Here's an example. Write an algebraic expression that represents the phrase 3 times the number t. So 3 times the number t, if we're timesing something, that means that we're using what operation? Multiplication or division? If you said multiplication, you would be absolutely correct. So we have 3 times the number t. So 3 times something, so it'd be 3 times t. We could also rewrite that as something else, right? 3t. You don't need to have the multiplication symbol. Remember, when it comes to multiplication, if two numbers are right next to each other, or two integers, variables are right next to each other, we know that that is multiplication, right? There's an implied times symbol right there. Okay? And remember, t is our variable. That can represent anything. So here's another example. Mr. Warren separated 30 students into n equal groups. Write an algebraic expression to represent the number of students in each group. If we're separating something, if we're separating a pile of Skittles into a number of different groups, what are we doing with our total group amount of Skittles? Are we multiplying them? Are we dividing them? We are dividing them. We're dividing our big batch into smaller, tinier groups. Nice job, guys. So Mr. Warren separated 30 students into n equal groups. First, we know that we're dividing 30. That's our whole, right? And we're dividing it by what? We don't know. We know that there are n groups. We don't know what that variable represents. So we would just divide it by n. What's another way that I could express this expression? What's another way that I could show 30 divided by n? If you said fraction bar, you are absolutely correct. So we could write 30 over n because that represents division. Now later when we have homework, you can absolutely do your 30 divided by n. That is easy peasy lemon squeezy. You could also show, I'm going to just show right here, 30. And then you can do the little backslash n. I would absolutely accept that as an answer as well. So when the expression equals something in this equation, then the number of students in each group need to be 5. For instance, we could replace, okay, Mr. Warren is dividing his group of kids, his 30s, into groups of 5, right? He wants 5 people per group. So we would just write 30 divided by 5, or 30 over 5. What's 30 divided by 5, guys? 6. Because 6 times 5 is 30. That is actually going to be the end of our first day. So what I want you to make sure that you have is I want you to make sure that you have your notes of this chart written out, okay? That's going to help you with your homework on tomorrow. And I want you to also think about just everyday situations. When are you dividing or multiplying what you do? For example, I know I can think of a perfect example right now. Making chili tonight. I'm dividing the amount of chili that I make into certain bowls because I'm meal planning. So I can know my pot of chili is going to feed 8 meals for my family, right? I can divide that up. Think about what you can do as well here, guys, okay? Besides that, I hope you have a great day. Pause the video. You guys are done. Alrighty, welcome back, guys. Happy Tuesday. We are going to look through our different examples here. So really quickly, though, let's review our phrases from yesterday. You should have these written down in notes. So if we're talking about multiplication phrases, right? Multiplication. 9 times k, that represents multiplication. Twice as many as m. Or 3 times as many as m. If we look at multiplying, we're going to notice that the number is increasing, right? So let's focus on division. So we have division here, my friends. 8 divided into n groups, that represents division. We know that. Q shared equally by 3 people. That's division, right? If myself, Javier, and Tristan are all sharing a pizza, we're dividing it equally. We're dividing one whole and dividing it into 3 different parts, right? Half of R, or a quarter of R, we say, hey, that's going to be ready in a quarter of an hour. We know that we need to split our hour up into 4 equal parts. Makes 15 minutes. We're dividing there, guys. Or 1/3 of P, that's another perfect example. We're splitting it up, right? We're splitting apart our whole. So we are going to be covering the examples. So let's look at example 1 here. Example 1. Earlier, we were given a problem about Ishmael's local bunnies. So we know that there are 127 females and 415 bunnies. Ishmael needs to write an equation that represents the average number of bunnies each female had. So if each female had the same amount of bunnies, how many would it take to get to 415? So we know our starting point was 127, right? We know our ending point was 415. So something happens to 127 to get to 415. Would that be, are they dividing? Do we start with, or do we end with less bunnies than we started with? Or do we end with more? We end with more. So are we dividing or multiplying bunnies? Are more bunnies getting made? More bunnies are getting made. So we don't know the exact number of bunnies, but we could just use a simple variable, right? N. So we could easily have an X right here, but that is optional. Optional because you don't need to have that X there. Remember, if we're multiplying a variable in a whole number or a number in general, you can just have them right next to each other. You don't need to have the X symbol there. Especially if we're working with variables, it gets kind of confusing. So do you remember what I did earlier this year? When I started writing everything with the dot to represent multiplication? You could have that if you'd like. All right, so let's look at example 2. We need to write a single variable equation for the following phrase. Keith, my guy Keith, he bought tickets to see movies. Oh, I miss going to see movies. The tickets were $8.50 each. Keith spent a total of $34. How many tickets did Keith buy? So we need to know how many tickets did Keith buy. We need to represent this phrase, right? We need to know what was the amount, but we need to write an equation to demonstrate what this amount was. So, my friends, how much did he spend total? How much did Keith spend total? He spent $34. How much does each ticket cost? $8.50. Now, how do we go from $8.50 to 34? What's our operation that we're using? Is it multiplication or division? It would be multiplication. So 34 T. So we can get this equation right here. That's our equation that we're looking for. That's all we're looking for. We're not trying to solve it yet. We're just making the equation right now. Now, that being said, we could use simple algebra to divide each by 850 each side. We would know that T equals 4, right? Because 850 times 4 is 34. But that's getting ahead of ourselves here. That's some 8th grade stuff right there, guys. All right, let's look at example 3. And remember, guys, if you have any questions about any of these examples, contact me during my office hours. That's what I'm here for. Or watch the Khan Academy videos that are in the link. So we need to write a multiplication or division equation to represent the following phrases. Example 3, 4 times a number is 8. Okay, a number. We don't know what that number is. So let's use a variable for that. Let's use x. And it's 4 times x, 4 times a number, equals 8. That's our answer right here, guys. That's all we need. Now, we know that x would actually equal 2, right? That's not what the question's asking. Okay, so let's not focus on what the answer is right now. Okay, so example 4, my friends. 16 candles divided into a number of piles is 2 candles per pile. So we know that we're ending up with 2 candles per pile, right? That's our equals. It equals 2 candles. But we are dividing 16 candles, right? By what? What are we dividing 16 candles by? x. But look here at example 4. Divided into means division, but be careful about the order. Is means equals. Okay, so let's look at example 5, and then we can move on here, my friends. So example 5, the product of 5 and a number is 15. So we know our total is 15. The product of 5 and a number. What does product mean? What operation is that associated with? Addition, subtraction, multiplication, or division? It's not addition or subtraction. It's not division. It is multiplication. So 5 and a number. So 5 times something. We don't know what that number is though, guys. So let's use a variable. It would be x. No, we could solve what x is, and we know that x is equal to 3 because 5 times 3 is 15. But right now, we are simply looking for this. So, my friends, we have completed this assignment. You are more than welcome to look through the textbook and read it for yourself. I would really, really advise you do that. But you guys have an assignment located on Google Classroom. It's a review. And you guys will then follow the rest of the weekly agenda. So we'll have some ALEKS, and then you guys will actually get some Prodigy time here at the end of the week. So I hope you guys all have a fantastic and wonderful, wonderful day. Love seeing you. Hope to see you during the office hours. Let me know if you have any questions. I miss you guys.